Hello again. We're going to continue our work by finding the yield stress. So for finding yield stress, we need uh, we need this plot, and then we need to actually go ahead and draw a linear line with 0.2% offset. And then when the linear part is crossing this, is actually intersecting this plot, the stress versus strain, then the intersection point is actually giving us the yield strain and yield stress. Okay, so this is easy thing to do. So let's have another plot of this. Okay, because we're going to work on that, and let's bring it here. Oh no. Let's bring it here, and then okay. Okay, so here's the point. In your instructions for the lab, it said that okay, when you have the stress versus strain, and then you have calculated your Young modulus. If you draw this line, if you plot this line, the intersection of this line with the stress versus strain will give you the yield stress. Okay, but the problem is that we have a bias here. You see, our linear part is not starting from zero. It's shifted this much. It's shifted this much. Okay, so what happens here is that you need to well, this part, you need to calculate this amount of shifted part, and then you need to add this shift to 0.002, which is for calculating the yield stress. Okay, so how can we do that? So we have, if we have y equals to ax plus b, the intersection of y with the x-axis would be the place that y is equal to 0. Okay, so x in that point is minus b over a. So what's a, what's b? Actually, a is the slope, which for in our case of stress versus strain is the Young modulus, and b is actually the bias term. Okay, so what we need to do is actually, in fact, adding minus, actually subtracting minus b over a from whatever we had before. Okay, so this is mathematically very easy shifting on the x direction. Okay, so let's do it then. Let's do it. So what is, let's say, what's minus b over a? Okay, I'm sorry, I don't need a equality here. uh, okay, let's say that's it. So what's minus b? What's minus b? Minus b is actually minus minus 101.12 over 200 373. Okay, and this is the amount. This is actually the place that this linear part is actually intersecting the x-axis. Okay, so for drawing the linear part, I'll make some data. Okay, I'll make some data. I'll say, let's say 0.00, well, 1, and then 0.002. uh, let's they are And then I will go ahead and let's make it a little bit finer. Let's make it a little bit finer. Okay, I'll go ahead, I'll drag it to probably this one is enough. Okay, and then here I have the formula. Okay, I'll have E 200 373 multiplied by what? Multiplied by my strain, okay, minus 0.002 minus this number 0.00505. Okay, this is actually minus b over a. Okay, I'll hit enter and then drag all the way down. I will have my data here. I'll have my data here. Okay, so there's been a mistake here because all of my stress are negative, so I'll go ahead and I'll check again my formula. I'll see that okay, I have 0.002 here, correct, but here I need to have 0.0035. Okay, so when I click this and then I'll do the drag here again, I corrected my formula which was incorrect, and then I have this stress versus strain here. Okay, so what I told you guys was that how you can actually add the data here. So let's add this data here. uh, I'll call this set as linear set. Okay, the x values for this are here, and then the y values for it is here. Did I select the y values correct or no? The x values. So they are the y values, and when I click OK, I'll have I have two lines here. One of them is the blue line, the other one is the red line. Okay, but since the axes are not really good, I mean not really good, we need to zoom in. Okay, so what we are going to do is that we are going to layout, we are going to access, then primary access. um let's say the maximum for this one is 0.004, and then you will see that this is the linear part and this is my data. This is my blue one is my stress versus strain. Okay, let's have the vertical axis as well a little bit zoomed in. Let's have it begin from 0 to probably 300 would be enough for us. Okay, so this is the point. This is the point. Okay, you can see the point here, which is 0.0036 and 219. But this is the problem. Okay, when you do the cursor thing, the cursor is actually snapping between the points on the red line. The red line was plotted with very far, like let's say widely apart data. Okay, what you need to do is that you need to select the data from the blue line. So we need to do what? We need to actually zoom in a little bit more. Okay, so I will say let's go ahead and zoom the x-axis from 0.0035 uh, 9 to, let's say, 0.365. Okay, this is my x-axis, and then let's zoom in the y-axis a little bit more, and let's have the y-axis from 222 to 223. Okay, so you can see that, let's have it a little bit, let's have it from 100 221 to, yeah, right now it's good. Okay, uh, if I double click on this data, it will give me the stress. While if I go ahead, the stress, uh, the strain, the yield strain is something about 0.00355. Okay, so 0.00355. So I need to find this number in this column. So how can I find it? Well, very easy. Match function, and then the value here, and then this column, and then find the exact number. Okay, that's because I'm using this 0.00355. Okay, 0.00355, 0.0. Oh, I'm sorry. I I'm this is the linear part. Okay, so I need to change this one. I need to change the place that we're looking for. Okay, so let's see what's the problem. So actually, let's go back to our analysis. Okay, so we need to find this number here. So in the strain, but where we should find it. Okay, so the problem is that we were looking at the wrong place. So we were looking at the three loadings and unloading stuff, but we need to actually go ahead and see our raw data. Okay, click on the raw data here, and then make it a perfect match, and then you'll see that uh, the row number 1245 is actually our data. Okay, so we come here to the raw number. I'll say go to 1245, and then you'll see that this is our strain and stress uh, for yield. Okay, so I'll write it down here, our yield stress, let's say strain first, and then our yield stress. Okay, and copy. Okay, great. It's not, it didn't copy. 12p 1245, and then I'll copy, and then I'll come here, and I'll paste them there. So this is my actually yield strain, and this is my yield stress. In fact, this one should be in megapascal, and this one should be in millimeter over millimeter, which doesn't have really a unit. Okay, so this is how you find your yield stress versus yield strain. Okay, so you need to have this plot, not zoomed in plot, actually the actual plot. Okay, you need to have it in your reports. Okay, so in case that you're making mistakes here, I know that what you have done will actually theoretically was correct, but your final answers are not correct. Uh, so I can give you some credits. Okay, but just zoom in a little bit so I can see the cross section crossing uh, with the blue line. Okay, so let's say a little bit here would be very nice. Oh, like this. Okay, so you need to have such a plot in your reports. And that was the yield stress. So in the next clip, I'm going to talk about the modulus of resilience and modulus of toughness.